Thank you, Martin. Delighted to be here to talk about applying AI to geoscience information to surface new knowledge. So geoscience, geology, supports the exploration, conservation of natural resources, so things like water, geothermal, minerals, oil and gas, mitigation of geohazards, things like landslides, earthquakes, volcanic eruptions, and then the geotechnical support of infrastructure, buildings, housing, everything. So it's really what's below our feet, the first few meters all the way down to several kilometers. So I'm going to try and mix a little bit of some of the things that we've talked with examples from the geoscience sector. Yeah, so a little bit of scene setting. Am I in the way there? And then some examples linked to Bloom's taxonomy, which is for the 1950s, educational outcomes, perhaps trying to frame lots of different applications of NLP search in a slightly different way. And then talk about RAG, which you've already heard of, but applications in geoscience with a summary. So why is AI particularly of importance to geoscience? Well, we have this net zero target at 2050. The energy transition is also a minerals transition. And as you can see from the chart there, we're just not finding enough of just about everything. So we need some new techniques to spark new lines of thinking. A lot of geological knowledge is held in documentation, and geology knowledge doesn't tend to go out of date. It's a little bit different from, say, IT or technology knowledge. So you can find something that's 100 years old, and it could be game-changing to the way that you're thinking about a particular area. So we need to apply the latest techniques to stimulate some new thinking. I'd like to talk about Iotvazite. So Iotvazite, this is courtesy of Jolyn Ralph, that created the largest definitive mineral database in the world. And he was looking for minerals with diacritical marks. And it particularly attracted to him this Iotvazite, because he'd never heard of it. So he spent a lot of time doing a bit of research, talking to colleagues. He asked ChatGPT for about what is, they'll give me a bit more information. It was discovered in 1950 in Hungary by this geologist Ferenc Iotvos. It's a uranyl carbonate found in Hungary and Arizona, and it's quite rare. So extensive research, couldn't find any trace of it. Asked to get scientific references. It all looks quite plausible. Connection with several of the other presentations that you've just seen. It's the mineral that never was, because it is completely fake. They did a bit of analysis of trying to understand why this came about. And they came across this Reddit forum, which is a Dungeons and Dragons discussion group. 616 is creating some imaginary minerals. Alchemist 19 is saying, what about Iotvazite? So it's a reasonable inference that this is why this mineral came about. So we went back to ChatGPT 4 and said, does it really exist, or did you make it up? But it doubles down. She says, well, it's found in the Czech Republic. And it also claims it's in the reputable mineral database of Mindat.org, which is his catalogue that he created. You can even find a picture of this imaginary mineral. So he's now created this page in the database. It's like an April Fool's Day, with the story of this fake mineral. So it's a good geological example, but it's so convincing that unless you really spent the time, or you're a mineralogist, you could have easily bought this as, perhaps referenced it somewhere else. So again, as many previous presenters have talked about, the hallucination effect. So I want to come on to the sort of explainable AI, and there's obviously a lot of research, a lot of discussion about this. This is the same issue, but coming at it from a data management point of view. A little bit of homage to Isaac Asimov. The 3 laws of data management in a frontier AI world. And the idea is to get some discussion and debate. So the first law, data must be managed as an asset, secure, legally, ethically compliant. The second law, the provenance, quality of data should always be known. And the third law is data must be discoverable and can be exploited by AI to generate new derivatives as long as these don't conflict with the first or second law. And you can argue, if you go along with this premise, that in many cases ChatGPT breaks the third law. And it's a little bit of a sort of a push to have data management staff in organizations get a lot more involved in some AI IT projects to ensure they don't, in a way, use data inappropriately. We'll talk maybe over wine a bit more about that. So these are some examples. I'm going to run through just a few of search and NLP applied into geoscience, but using Bloom's taxonomy. So this is still used in teaching today. When we learn, we have to remember, we have to understand what it is that we're learning, apply it in new situations, analyze, make connections, evaluate, critique, critical thinking, people mentioned, the quality of information, and then we create new original work. So just like any model, it's a conceptual abstraction, but if we put some of our sort of explicit documentation on here, we have containers or chunks of information. We break those down into their different components, their entities, the concepts, and so on, and then we reform them into new information. So I'm going to introduce some examples, and you'll see this sort of pyramid build up. Each layer builds on the previous layer, but it's not an arrow of time. So you can go up and down the pyramid as you'll see with some examples. So remembering, if you map this to our space, is a big part of information retrieval. Search engines, Google-like experiences that have been so successful. And it's like most organizations, they have a Google-like experience to try and replicate what's on the web. And these algorithms, you know, they curate what we see through their ranking, and therefore they influence what we know. So they have become an epistemology for how, inside organizations and outside, we come to know many things. There's lots of benefits, some drawbacks with that, but they've augmented our capability, this exo-brain of what's written down inside organizations, what's written down outside, to complement what we know. Classification, of course, like named entity recognition and classification of images in documents or objects on those images can also help us understand, and they can interrelate with one another. I'm going to move up to apply and analyze. I just want to introduce this tool. It's going to be made freely available in the geoscience discipline next year. So I've been doing some volunteer work with Geoscience World, which is a non-profit cooperative. It manages a big chunk of the world's geoscience literature, and they have a traditional sort of Google-like search experience. And the intention is to complement it with more of a data discovery tool on top of their literature. So I'll just go through what we do, what we're doing. There are around 4.5 million geoscience research articles. So we built a text embedding model from that text within a Python function so that we could interrogate the model. We then loaded in hundreds of thousands of geoscience taxonomies and relationships, with also place names, geological localities, city names, and the lat longs, and then ran named entity recognition as well to extract out things that are better through using machine learning or a rule rather than a taxonomy, such as geological formation names. And then built a user interface which is containerized on the top to allow people to explore the whole corpus in one go. So rather than searching, having lists of documents, we're now searching that statistical model with the view that you put it all together from all of those authors, then the whole is greater than the sum of the parts. There may be knowledge that we can glean that is not present in any single report. This doesn't replace the traditional search, because there's definitely a continuing need for that, but it interacts with it. I'll just go through a couple of workflows to show you how that might work. So here we're searching on two terms, the Slanos Basin and the Piceance Basin. So these are just depressions in the earth. You get sediment, kilometers of sediment deposited. There's around, over geological time, around 4,500 basins around the earth. So we're just going to compare these two basins. I want to look at rock types. So that might be things like basalt, sandstone, different types of rock, and then a 2D cross plot. So what you're seeing here is all of the lithologies compared to each of those by vector. So what you're seeing on the x-axis is the cosine similarity of all of these lithologies to the vector of the Thanos basin. So the further they are this way, the more similar they are to the Thanos basin. And on the y-axis, the same thing with the Picayance basin. The further they are to the top, the more similar those are to the Picayance basin. So you can see, I don't know if you can see with this level of detail, but the green triangles and then the purple inverted triangles, volcanics igneous, it's a little bit more similar to the Thanos basin, whereas we've got red circles and yellow right pointing triangles as carbonates and salts being a little bit more similar to the Picayance basin. So we've been testing these approaches to help geoscientists experiment, come up with hypotheses, sort of spark a line of thinking that they wouldn't have had if they hadn't had this sort of interaction with a discovery tool. Here's another example, this time dolomitic and aquifer. So an aquifer is like a porous rock between the grains. And there are many aquifers in the UK. You get water which you can use for drinking water. So aquifers are very important in terms of hydrogeology. And what we're doing is just adding those two together. So the vector for dolomitic and aquifer. And then these are the most similar geological formations, just doing a straightforward cosine similarity. So the interesting thing with analogues is that you don't know what they are, so they're quite difficult to search for. So sometimes it's useful to be a bit more data driven and see what comes up. So here we've got the Ratner formation. There's a few terms that are saying these are the terms that are shared by both that vector and that combined vector. And then you can query, go to your traditional Google-like search interface. So I'm now going to read some documentation on the Ratner formation, which I wasn't aware could be a possible analog. So in this model, we've started up here because we're drawing connections between things, and that's then stimulated us to make a query that we wouldn't necessarily have made if we hadn't been stimulated. So it's not just that the pyramid goes that way, you can see it in a way it could create more of a need for traditional search as well. So final example here, this is a transgressive, which is sea level rise. So when the sea floods over the land. And this time we've got a display by geological age. So here's a Precambrian, so it's 4.6 billion, Cambrian 570 million, all the way up to present day. Then you've got the similarity again on this axis, so the closer to 1 over here, the more similar that geological age is to that vector. You're seeing the variance there in the box plot because each of those ages has a whole set taxonomy underneath it. So they're all being compared, which is why you get the range, and then the median line you can see in each of the box plots. So what you're trying to do is use the patterns of words to stimulate something that doesn't fit with the geoscientist, and they could drill down. It might be it's a data artifact. It might be they can explain it away, but it also might be that it just stimulates like that line of thought that comes up with a new idea or new theory. So if we take this median line, and then this is the global sea level fluctuations based on real data. There's many different interpretations of this. This is only two, but there are many different ones. So here's a Cambrian, here's present day, and then we can overlay our curve. So I'm not going to explain the correlations or the differences, but it's again, if you stack up all this information, then you can use it to challenge the scientific orthodoxy. And there are papers published where people had always thought this was the case for a particular geological theory, and then they've used large amounts of geological papers to actually say, well, hang on, there's evidence here that points it's more likely to be another reason. So I think it's a little bit underused by putting a tool directly in front of so many geoscientists. Hopefully we'll be able to stimulate a lot more of this type of exploration. So retrieval augmented generation, lots been said already, in far more detail than I can offer. I'm just going to offer my 2 pennyworth of what I observe in some organizations. You can tune a large language model for geoscience. Deng was the first to do it this year using Llama and 1.2 million documents from Deep Time Digital Earth. It was a bit underwhelming, and it's not the first time I've seen fine-tuning of a language model produce results that are not great. I'm sure it will have evolved further, but of course you don't need to do that. You can use large language models in a RAG arrangement. So I observe organizations with MongoDB or SharePoint with all their documents. They create their vector database through chunking. How you chunk text has a big impact on the responses that you get. Once they're in the vector database, you can enrich or via a search index, enrich with additional tags through natural language processing. That also has a big impact on the response that you get out. Then you can match your prompt to the chunks to get the top candidates using an embeddings model, which could be generic. You could fine tune your own one. That also has a big impact on the response you get to the LLM. And then your prompt, which also has a big impact on what you have. So there's a lot of elements that can affect it. So this is just using ChatGPT 3.5. It's about 10 lines code in Python, just saying where are source rocks in the Sumatra Basin. And I'm just saying get it from the out and make sure that you put the file name of where you got the text chunks. So here's the example. Here's the references for each of the assertions from files here. And what I've been doing, it's a bit early to share the results. There's no statistical significance yet, but I've been testing various responses with retired geologists to see what it is that they find most useful. And one of the things that's emerging is that a lot of the responses are quite truisms. They're like obvious generalities. The language model is not really producing anything for a subject matter expert that really sort of gets them interested. And the influence of this, which I find in a way interesting and slightly ironic, is that we found with enterprise search the importance of metadata. Despite all of the algorithms, metadata was very important for enterprise search. And it could well be, someone mentioned about common themes coming around. It could well be in this AI space that metadata is just as important in the responses that we get as in the enterprise search world. So I've got to finish off with just some examples of people that have deployed and organizations that have deployed these conversational assistants in geoscience. This was the Norwegian government. It's been running for 6 months, 55,000 questions, 400 users. I mean, I think they'd be open for a researcher to get hold of that data, which would be an interesting study. So here's an example. Please provide examples of prospects with downfaulted traps. And you can see here's the results coming from 2,000 documents with the references. In terms of their learnings, I'll just focus on these three here. When you have a small amount of content, it's quite difficult, it appears, to get across to the users that they can't ask any question they want. In other words, it's narrowed because of the nature of the content. And they found that there were people asking questions that simply couldn't be asked in the content, struggling to see what was in there. The second point is almost unanimously, people want a keyword search. So they implemented a keyword search. So alongside the writing the questions is having the ability to search that corpus as well to get a feel for what sort of content is in there. And the third one, I'll read this out because I quite like it. As with any LLM solution, managing hallucinations is important, as well as teaching users that you should never fully trust an LLM. LLMs are truthy, not truthful. I've never come across the word truthy. Maybe it's a Norwegian translation, but in a way I quite like it.
Oh, I've come across it before.
Truthiness.
Truthiness, yep.
I stand corrected. I apologize.
Iraq War thing, I seem to be. It was an American newsreader that said it was a truthy. What he said was truthy. American government, I believe.
So that was one of their takeaways from that. This is an example where they're using immersive virtual reality to reconstruct a natural a disaster, in this case wildfire. So they're gathering together soil moisture, burn scars, wind direction, to create simulations for the emergency services and then local governments. And one of the things that I found interesting is they'd incorporated a conversational assistant in this. So as well as being able to immerse yourself and for people to learn what happened during a particular disaster, you get a lot of these big PDFs, hundreds of pages long, produced by various governmental departments. And so they can ask sort of questions whilst they're sort of immersed in this virtual reality. I just hadn't seen, I often see these conversational assistants almost on their own as a text-based thing. I thought it was an interesting one to see this with a sort of immersive virtual reality example. And then finally, this is another one. This is basically very closely tied to a map. I just included it. What's the porosity? And the Huygens formation is obviously beginning to show the images as well as the text, which we know, certainly from your science point of view, people want images and text, certainly, and you know that's coming. And then I think someone mentioned it earlier about being prompted about what questions can you ask based on the content. And that's obviously a huge area, I think, of potential research to start suggesting questions that people can ask based on the content. And again, similar lines to how we've done with, you know, recommended queries and so on. So, you know, in summary, it may make a lot of sense to adopt this sort of 3 law safe to avoid loss of trust. We all know once users lose trust, it's quite difficult to get it back. Continue to innovate with new tools that complement, you know, the existing Google-like approach. And as well as finding things faster, you know, the productivity angle. I think one of the really exciting things is just being able to find new knowledge in these vast information resources, which you know, could have some pretty significant impacts in various disciplines. So thanks for listening. Happy to take any questions.
Can I just set this up while
Yeah,
you're
sure.
doing your questions?
So to what extent is language an issue? I would guess a lot of local geological material is in local language.
Yes, I mean, so one of the things with translation, so Spanish or Portuguese, is that a lot of the main nouns don't get translated very well. So the everyday English seems to be okay with some of the translation, but particular domain terms don't. So that's something that needs to be modelled, my experience, with some sort of taxonomy.
So, yeah, I mean, in one of the things that hasn't come up today is language management in any of the presentations. And it always intrigues me because there's always so much local content. I mean, I guess in Welsh, there must be, I'm sure there's some Welsh.
There is.
Geological content. Yes. Andrew.
Quick one there. In the end there, you said there's suggested prompts. How are you getting those suggested prompts? Are you getting the LLM to suggest them, or are they coming from previous use? Or
Yeah, so that was Icon Science's version. I believe they're driven by the content. So you can provide a set of content, and then you can just change the prompt and say, based on this content, what questions could I ask? And so then, you know, those questions could be, you know, then surfaced to you know, when you have the box that says "Ask me anything," I think sometimes people
page problem. Yeah. I was interested there to get the LLM, because we've done a little bit of work on that as well, to get the LLM to tell us what questions it would ask. They might provide some insight.
Yeah.
I said the back.
You showed some periodization. So you know, things like sort of geological timescales, and presumably you're extracting those from natural language. You have the benefit that you don't know how the generative tools are using it, but you know what you're doing. So do you have a sort of like a confidence score? I mean, if you say it's Permian, how do you know that you're just extracting that from the word Permian using the natural language?
Well, if it doesn't exist in the text, you won't even see it on the charts. So it's when you create like an embedding model, you can say, you know, the word has to occur n number of times for it to be in the model. So you can sort of force it that if it's not mentioned that enough times, then it will show you there's no data. You know, so you won't get a result from it.
If it says this doesn't occur in the Permian, does it pick up negatives and things?
In that particular model, if it's not in the vocabulary, it will just ignore it. So it will just, you won't see the data that's there in that particular scenario.
One of the things about geology intrigues me, the comment you made was how old, if you like, some of that material is. And having spent a chunk of my life in metallurgy, you realise that a lot of the work that's done on steel, on ferrous and non-ferrous metallurgy dates back to like the 17th and 18th century, and basically hasn't need to be redone because it's iron. So there's big gaps in the corpus if you actually want to find out some of this fundamental research.
Yeah, I mean, it's a very large scale scanning projects that, you know, governments are sort of undertaking. And, the thing is also, you know, perhaps people are not going to be flying all over the place as much as perhaps they've done in the past for various reasons. But there's a huge amount of knowledge. I think, you know, by putting it all together, it's got to be close to a high probability that there's knowledge there in this enormous collection that we haven't discovered yet. And there's a paper in Nature where the researchers took about 1 million material science papers, and they only took the ones pre-2009, and they compared chemical compounds to thermoelectric as a vector. And then they got the top 5 compounds, candidates. And based on the 2009 data, they could have discovered some thermoelectric compounds that were only discovered 7 years later through this text mining approach. And I mean, in that sort of sense, it always goes back to the mid-80s, where a chap called Swanson looked at medical literature, and he found there were some connections between magnesium deficiency and migraines, but it was never mentioned in any paper. But there were concepts that were shared between those two concepts. So he hypothesized that there might be a link between magnesium deficiency and migraines, which was later proved. And that was through the original LBD or literature-based discovery technique. You think of the compute power and the algorithms we have now, you know, if we can get more minds on this, then hopefully we'll make more new discoveries.
There's a famous example in the States going back now 50 years or so, when there were about tetraethyl lead used as a petrol additive, and the environmental groups did a huge amount of research putting together, you know, lead in information about lead in the atmosphere and the health of children. And there was another parameter of distance from road. And for the first time did a mashup of this. And even though it really was a bit of a mashup, it frightened the petroleum companies out of their skins when they saw it. Because it was all public information, but it hadn't been brought together in that particular way to show the interrelationships.
I mean, creativity is just making connections, isn't it? You know, with the tools that we've got, we can make a lot of connections.
That's why we're all here today. Oh, thank you very much indeed. Very interesting.